Now that you're done practicing prime factorization, let's take a look at a few more definitions as we get ready to simplify these square roots, or in this case, radicals. And a radical is just an expression involving a root, such as a square root or a cubed root. So as you can see here, you got your basic square root of x, or you have your cube root of x, noted by that that 3 right there. If we don't see anything over here, we just assume that that's going to be a square root, and it should really just be like, a 2. Now, the important part here is when you start square rooting, the inverse operation, the square root is the inverse operation of squaring. So if we look at that, 4 times 4 is essentially 4 squared, which would equal 16. That is squaring. If we take the square root of 16, it brings it back to your 4. The same thing would go if we look at cube roots, which would be your inverse operation of cubing a number. And that would be like saying 4 to the third power is 64, where if we take what we call the cube root of 64, it comes back to that base of 4. So when we look at starting to simplify square roots, it's going to be very helpful if we have these perfect squares and these perfect square roots in mind. So listed below here is a kind of a progression of what we see with your perfect square roots that we kind of been working with. If we have 1 squared, that's the 1 times 1 equals 1. If we have 2 squared, that's really 2 times 2 equals 4. 3 squared, 3 times 3 equals 9. And kind of continues down the pattern. Now, when we start looking at simplifying the square roots, these perfect squares are going to be ones we want to look at, or kind of have always in the back of our mind. So if we look at the 16, we know that breaks up. That's the same as 4 times 4. So we could have that inverse and say, oh, square root of 16 is 4. Jump down here to 81. Well, that's 9 times 9. So if we are trying to take the square root of 81, because we have that factor pair, we could simplify that base of 9. Okay, so let's kind of put that knowledge to work here. So if you're looking at simplifying the radical, this is going to now be with no decimal, so it's going to kind of take away from just plugging it into your calculator and spitting out those, irrational decimal answers. Easiest way we're going to look at this is going to be using that prime factorization. So if we look at 44, we're going to be looking for some type of perfect square. And if we break down the 4 and 11, okay, that's probably jumping out to you at that 4 is a perfect square. Because if we break that up into, 2 times 2 times 11. So the way I want to look at this is if we break down 2 times 2 times 11. Now remember, this is all under that square root. So both part of these, we can kind of break this into 2 sections now. What we're looking for, since we're looking at square roots, is we are looking for those pairs, 2 times 2. And just on that last part, that square root of a 4, or we have that pair, that can simplify just to a 2. Now the square root of 11 is on its own, and really, that's what we're looking for. Now, that's going to be the easiest way, surefire. Now, there is kind of a little bit of a shortcut if you kind of look at this first step here that we did with the 4 times the 11. If you recognize that these perfect squares, you could just jump and say, oh, I know the square root of 4 is 2, and then we have 2 root 11. We could end up working with that. But then we just got to be careful that we are making sure that if we had that square root 11, we didn't miss any other perfect squares within it. So a lot of times we like to see you kind of work through to the prime factorization just to make sure. Let's take a look at another example. If you look at 300, again, let's kind of break that down. Looks like it's divisible by 100. So we could look at 3 and 100. Now, if we see that, right, 100, if you recognize that as a perfect square, that is kind of just saying 100, square root of 100, times the square root of 3. We can kind of break those 2 factors apart. And we know that the square root of 100 is 10. So we could just jump right there if you recognize it. Now, if that isn't jumping out to you, continue your prime factorization. which is a lot of method. Well, now what's the two factors of 100? So we got 10 and 10. Again, that might be a good spot to say, oh, there's a pair. I could pull them out. But let's just break it down all the way to the prime factorization. And this is where I would take a second just to kind of relist them out. All right, we got 2 times 2. That's a pair. We got times 5 times 5. That's a pair. And don't forget about that square root of 3. So using our knowledge of those perfect squares, if we can find a pair and we can find another pair, what's really going to happen here is, say, 2 times 5. Now this square root of 3 does not have a pair. So the only thing we'd want to do is take one more step to take that 2 times 5 and say 10 square root 3. Again, kind of detoured up here at the top, but if you see those perfect squares, you know, you could end up maybe saving yourself a little time. Otherwise, finish out your prime factorization. Once you get to these final prime numbers, you are looking for your pairs, because those pairs will then kind of simplify where we can get rid of those square roots and bring them back to the base of 2. Okay, take a few minutes here to stop and practice these 1.4b. Practice these 6 examples before you move on, check your work, and take a look at another one. All right, good luck.